This is the video on section 1.4 on angles. An angle is the figure formed by two rays that have the same endpoint. So this picture I have drawn here is a picture of an angle. We have two rays, ray BA and ray BC. They share the same endpoint, endpoint B. So they form an angle. Now we can name that angle in certain ways. We could call this angle angle B, and that's a symbol that we use for an angle. We could call it also angle ABC. If we use three letters to name an angle, the middle letter has to be the vertex of the angle, has to be the point that the two rays meet at. So B is the vertex, that's why B is in the middle of our three letters. We could also go the other direction and name it angle CBA. Again, B has to be in the middle, but it doesn't matter if we put A first and C last, or C first and A last. We could even call this angle 1, because I've numbered it with the number 1. When you have a diagram with a lot of angles in it, often there will be numbers to designate the angles rather than letters, because that's easier when you have a lot of angles. Now, let's say if I were to talk about angle B, everybody knows which angle I'm talking about, because there's only one angle there that has a vertex with B. Well, let's look at this picture. If I were to ask you about angle E, we don't know which angle I'm talking about. Angle E, is it angle RES? Is it angle SET? Or is it angle RET? We don't know. So we can't name an angle in this picture angle E, because we don't know which one we're talking about. So in this picture we have to use three letters. And which three letters we choose determines which angle we're using. Okay? Now angle RES is angle 2, as I've labeled them here, and angle SET is angle 3. And of course, angle RES is the same as angle SER, angle SET is the same as angle TES, angle RET is the same as angle TER. Again, E has to be in the middle of each of those, because it is the vertex. Now most of you, I'm sure, have seen one of these before. It's called a protractor. Protractor, spelled like that. Protractor is a device used to measure an angle. In this class, for now, our angles will be measured in degrees, where the degree symbol is a little circle to the right of the number. There are different titles for different size angles. If we take a look at angle WOZ, we could say the measure of angle WOZ, where M stands for measure, is equal to, and we could look at the diagram, and it's approximately, looks like 31 degrees from there to there. Now there's two ways that I can write that. I can write it with an M and an angle symbol with that little marking through the angle, or I can write it with an angle symbol and not a little mark, like that. Without that little mark means that I'm talking about the number, the size of that angle. with that little mark like we have here means that I'm talking about the angle itself, not its measure. Okay? So if I want to talk about the measure of the angle, I will mostly be using this notation. Your book uses mostly this notation. Either one is acceptable. It does matter, though, whether you put the mark on the angle or not. You put the mark if you're talking about the angle itself. So here we're talking about the measure of angle, WOZ. We're talking about the angle. Here I'm talking about the size of that angle, so I don't put the mark. Okay. Since angle WOZ is 31 degrees, it is smaller than 90 degrees. And any angle that's smaller than 90 degrees is called an acute angle. So an acute angle is an angle whose measure is between 0 and 90. Now between does not mean it equals 0 or 90. It doesn't. An acute angle does not have a measure of 0. It does not have a measure of 90. It is somewhere between 0 and 90. An angle whose measure is 90 degrees, called a right angle. Measure equal to 90 degrees. An angle whose measure is greater than 90 degrees, called an obtuse angle. An obtuse angle is an angle whose measure is between 90 degrees and 180 degrees. And then an angle whose measure is exactly 180 degrees is called a straight angle. So, in our picture here, a straight angle would be angle XOZ. So any line forms a straight angle. Angle WOZ is an acute angle. Angle VOZ is a right angle. Angle YOZ would be an obtuse angle because its measure looks like, so this is 55. Then its measure is 180 minus 55, which is 125. So that's between 90 and 180. Now, I just had a protractor pictured here, but what tells me that I can always form such a thing? Well, last time we had the ruler postulate that said if we had a line, we could pick any point to be 0 and any point to be 1, and we could make a ruler out of it. We have a very similar thing called the protractor postulate for angles. And it says, if we have a line, so here line BA, or line AB, we're able to choose any point that we want. We call it O for origin. We can choose any point between A and B on our line. And then we can consider ray OA and ray OB, and all the rays that can be drawn from O on one side of angle AB. Or any of the rays that can be drawn in this arc here. These rays can be paired with real numbers between 0 and 180, in such a way that OA can be paired with 0 degrees and OB with 180 degrees. And if OP
P is some point out here. OP is paired with the number X, and OQ paired with the number Y, then the measure of angle POQ is simply the absolute value of the difference between X and Y. So all the protractor postulate is saying is we can always measure angles. We can always take a line, mark out an origin, mark out the angle that we have, and another ray, and we can find the measure of the angle between them. That's all the protractor postulate is doing. It's very basic of an idea. It's a very basic idea. But it allows us to then be able to do other things with it. So it's just basically saying we can measure angles, is what the protractor postulate is saying. Now, a related postulate is called the angle addition postulate. The angle addition postulate says, if point B lies in the interior of angle AOC, then the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. You can see that on our picture here. B lies in the interior of angle AOC. Since that's the case, this postulate says we've met our hypothesis. The conclusion then is angle AOB, which is this angle, plus angle BOC, that angle, equals angle AOC, the whole thing. Pretty simple idea. Very much similar to the segment addition postulate we had in the last section. Also, in the angle addition postulate, following from this first statement, we can make a statement specifically about straight angles. Where a straight angle is a line, an angle with a measure of 180 degrees. If angle AOC is a straight angle, and B is any point not on line AC, remember we write a line with that symbol over it, then the measure of angle AOB plus the measure of angle BOC. Well, our first statement says that's the whole angle, angle AOC, but we know the measure of angle AOC, because it's a straight angle, it's 180 degrees. So this statement that I just wrote, that I'll now highlight in blue, follows directly from the first statement above it. Just using the fact that angle AOC is a straight angle, so we know its measure is 180 degrees. We can fill in that number in our equation. That's the only thing that's different between this equation and this one. Okay? So that means if I know, for instance, that angle BOC, let's suppose that is 160 degrees. Angle BOC is 160 degrees. Then I do know what angle AOB has to be, because angle AOB plus 160 degrees, because that's the measure of angle BOC, has to be 180 degrees. So that means angle AOB must be 20 degrees. Okay? Because adding it to 160 needs to give me 180. Now, a few more definitions. Congruent angles, just like congruent segments, are angles that have the same measure. So congruent angles are angles with equal measures. If two angles both have the measure of 50 degrees, then those angles are congruent to each other. Adjacent angles are two angles in a plane, so in the same plane, that have a common vertex and a common side, but no common interior points. Let's see an example of adjacent angles. There's a ray. There's a ray. Let's say I draw a ray in between them. Then this is angle 1 and that's angle 2. Angle 1 and angle 2 are adjacent angles. They share a common vertex, this vertex right here. They share a common side, this ray in between them. And they don't share any common interior points. It means there's no points on the inside of the angles that are shared between the two of them. That's clear because the interior of angle 1 is down here. The interior of angle 2 is up here. And they don't overlap at all. Another example of adjacent angles would be something like this. That's angle 1 and that's angle 2. Angle 1 and angle 2 are adjacent angles, even though their vertex now is just this point on the straight angle there. They share a common vertex, they share a common side, they don't share any common interior points. So those are adjacent angles. What about these angles? Okay, let's take angle 3 here, angle 4, that's because they all meet at the same vertex there. Are angle 3 and angle 4 adjacent angles? Well, they share a common vertex, but they don't share a common side. Angle 3 has that side, and angle 4 has that side, and those two sides aren't the same. So they're not adjacent angles. Another example would be a picture like this. This is angle 3 and that's angle 4. Angle 3 and angle 4 don't even have a common vertex, so they can't be adjacent angles. Now what about this no common interior points thing? Why do we need that? Well, let's look at this example. Let's say this angle is angle 3, this whole thing is angle 4. Now they share a common vertex. They share that vertex. They also share a common side. They share that side on the bottom there. But they also share common interior points. They share all these points in here. The entire interior of angle 3, for instance, is also in the interior of angle 4. So those cannot be adjacent angles. That's why we need that third condition. Okay, one last definition. The bisector of an angle is the ray that divides the angle into two congruent adjacent angles. we have this large angle, which we can call angle X, Y, Z. And then we have this angle that goes straight through it, and maybe that's a point W. Then ray YW bisects angle XYZ if angle XYW equals angle WYZ. So let's suppose this is 30 degrees and this is 30 degrees. Then the statement is true. Okay. Now your immediate practice problems. Let's take this picture over here. And we want to figure out what information we can know just from that picture and what we talked about in this section. So we have angle FOB that's 50 degrees, and line AB forms a straight angle. And O is the vertex of all of these angles. So from the diagram at the right, can we conclude, number one, that angle AOC equals 90 degrees? Just write yes or no. And number two, angle AOF equals 130 degrees. Just write yes or no. That is the end of section 1.4.